In this lesson, you will solve systems of equations by using elimination by multiplication, and then solve real-world problems involving systems of equations. So remember elimination, it is getting rid of one variable. You can choose to get rid of the x, or you can choose to get rid of the y, but you have to get rid of one. So let's try example 1. In example 1, you can see that we do not have any like x's, we don't have any like y's. So that tells us we're going to have to multiply. And think of it like making a common denominator. We need to make a common x or a common y, and I want to make sure that one of them is opposite the other, so I can just add. Because elimination by addition is probably one of the easiest ones to use. You don't have to change signs or anything like that. So what I'm going to do is I am going to make this 3 into a 6. Why? Because it's hard to make a 2 into a 5 by multiplication. I mean, you can do it, but it's going to be kind of ugly. I can easily make a 3 into a 6 by taking it times 2. And I want to change the sign, so I'm going to multiply everything in this denominator by a negative 2. So that first equation, 5x plus 6y equals negative 8, stays the same. Don't have to change it at all. My second equation becomes negative 4x, I'm just multiplying by negative 2, minus 6y, once again, just multiplying by negative 2, and then equals 10. Like I said, multiplying by negative 2. Now I'm going to add because I have opposite coefficients like we talked about. So it's 5x minus 4x, which is x, and then I have equals because we've eliminated the y, negative 8 plus 10, which is 2. So my x value is 2. Now you do have to plug in the x to find the y, so we're going to plug into the first equation. 5 times 2 plus 6y equals negative 8. So this is going to be 10 plus 6y equals negative 8. I subtract 10 now, subtract 10, and I get 6y equals negative 18. I now divide by 6, and I get y equals negative 3. So I put my coordinate then as my solution to negative 3. You try the example in your notes. Now we're going to look at an example where you have a possibility to eliminate either the x or the y. Here's what I mean. I cannot make a 3 into a 4 or a 4 into a 3, and I cannot not make a 2 into a 3 or a 3 into a 2. So that tells me I have to multiply both. So when you multiply both, you can eliminate the x by getting them to be a like coefficient but opposite. So I really think the best common here would be 12. And in order to get a 12, I'm going to multiply the top equation by 3. I'm going to multiply the bottom equation by a negative 4. Why negative 4? Well, I want one of them to be negative so I can add. So my top equation is going to be 12x plus 6y equals 24. I just multiplied each by 3. My bottom equation is going to be negative 12x minus 12y equals negative 36. So now I'm all set to add, and I will be eliminating the x. Now I want to show you how you could eliminate the y here, because you could. If I wanted to eliminate the y, what I would do is look for a common y. I think 6 would be the best. So I'm going to multiply everything in the top by 3. In the bottom, I'm going to multiply by negative 2. Why negative? Well, I want to have an opposite relationship so that I can just add. So my top equation is going to be 12x plus 6y equals 24, multiplying each by 3. My bottom equation is going to be negative 6x minus 6y equals negative 18. And now, as you can see, I'll eliminate the y. Now, you don't have to do both of these. You can choose to just eliminate one variable, and then you can just substitute to find the other variable. But since we do have both of these set up, let's just go ahead and find x and y. So in this case, this x cancels. This would be negative 6y equals, when I add, I'm going to get a negative 12. I divide by negative 6, and I get y equals 2. To find what x would be, I'm going to add 12x minus 6x is 6x, these y's are gone, is equal to 24 minus 18, which is 6. I divide by 6, and I get 1. So my solution is 1, 2. Now, like I said, you don't have to do both of these. Just eliminate one variable, and then you can use substitution to find the other. So you try the example in your notes. All right, your favorite, real world. In our real world problem here, I'm going to have a table to help me out because I'm working with distance. And distance formula is D equals RT, which is distance is equal to rate times time. So I have a rate column, a time column, a distance column. And remember, rate is something like miles per hour, okay? A personal aircraft traveling with the wind flies 520 miles in 4 hours. On the return trip, the airplane takes 5 hours to travel the same distance. Find the speed of the airplane if the air is still. Well, that tells me what I need to find, the speed of the plane when I have still air. So that's going to be my x. So I'm going to say let x be speed in still air. Now, what's the other condition that I have? I'm going to have that be my y. Well, that's when I have wind involved. So that is going to be the speed in wind. And you can use some different language for that, but that's basically the point there. So my rate when I'm going with the wind. Think about times when you go with the wind. When you're running, when you're biking, it helps you. It makes you faster. So that's going to be an x plus y relationship. Just think about that. Because I have my speed in still air, and then I'm adding to that with my wind behind me to push me. Now, what about going against the wind? Have you ever tried that? Biking into the wind, running into the wind. It pushes you back, slows you down. So that's going to be a subtraction relationship. Now, what do we know about time? Well, we know that this with the wind, right here, with the wind, is 4 hours. And we know that against the wind, if you look here, is 5 hours. My distance is 520 miles, and it says the same distance, 520 again. My last column is going to be a multiplication relationship of my rate times time to equal my distance. So that's going to be 4 times x plus y equals 520. And we can distribute that out for our work in a little bit. And this is going to be 5 times x minus y equals 520. So let's go ahead and set it up. Let's distribute it. So distribute the 4. We have 4x plus 4y equals 520. Now let's distribute the 5. 5x minus 5y equals 520. Well, if we want to eliminate, can't make a 4 or 5, yeah. But I do have an opposite relationship here, so let's shoot for their common factor or common multiple, which might be 20. I think a 20 would be good here. So we're going to multiply this by 5 to get 20, and we're going to multiply this by a 4. And we don't have to worry about a negative here because we already have a negative positive relationship. So this is going to be 20x plus 20y equals, if you multiply that on your calculator, you get 2,600. You can check it if you want. And then my bottom is going to be 20x minus 20y equals 520 times 4, which is 2,080. And you can double check if you like. Well, I have an opposite relationship, so I'm going to add. So this is 40x equals 4,680. I divide by 40, and I get x equals 117. Remember what x was? My speed in still air, and hey, that's what I wanted to find out. So my solution is going to be 117 miles per hour. That is my speed in still air. You try the real world example in your notes.